the last FRQ is function mashup. And so this one we have 3 different functions. So for G, we have a table that gives us values of G and values of G prime. We have H, that is this graph, and then we have F, which is written algebraically. All right, it does tell you that G is a differentiable function. It does tell you that this is 5 line segments. That's kind of obvious. Okay. And then part A asks us to find the slope of the line tangent to the graph of f at x equals pi. And so it is not asking us to find the tangent line. We could, but you would waste some time if you did that. All we need to know is the slope of the tangent line. So what do we need to find the slope of the tangent line, or the SOT? What gives you the slope? The derivative. Thank you. It was not a trick question. All right, so we need to take f and we need to find the derivative. There is 2 chain rule problems in it. So this one, we're going to have to do the chain rule because it's not just the cosine of x, it's the cosine of 2x. And this one, we have to do the chain rule because it's not just e to the x, it's e to the sine of x. So let's do that. All right, so the derivative of cosine of something is negative sine of that something times the derivative of that something. So that would be negative 2 sine of 2x. All right, and then the derivative of e to something is just e to something times the derivative of that something, which is going to be cosine of x. And you can write that in any order. You could write the cosine after the e. It's fine. It doesn't matter. All right, I would guess you would get a point for doing the derivative correctly. And then because I want the slope of the line tangent of f at x equals pi, I'm going to need to plug pi in for x. And if I didn't need this to do something else in this problem, I actually need it a couple of times, I think. Yeah, I need it on part B, and then I think I also need it on part C. You could stop right here. Well, it feels like you should do the sine of pi but in the cosine of pi, but you actually don't have to, but we do need it later. So you might stop here and then do some more, and then you would have to come back to it, but let's just go ahead and finish it because I'm telling you that you need it later. Okay, so what is the sine of 2 pi? 0. And the cosine of pi? Yes, you're right, negative 1. All right, and then e, and then what's the sine of pi? 0 again. What's e to the 0? 1, so this ends up being 0 minus 1, or just negative 1. Right, and so throughout this question, you're going to need to use f prime of pi, and when you do, you're going to use negative 1 for it. All right, don't underline it on your answer, though. Sorry. Don't underline or box anything. Okay, so let's look at part B. Part B says to let k be the function defined of h of f of x, and we want to find k prime of pi. So what we need to find first is k prime of x. And this is basically just the rule or the definition of the chain rule. And so if k is h of f of x, then k prime is going to be h prime of f of x times f prime of x. So if you've been studying the flashcards, that's pretty much what the rule is for the chain rule. Except I think it's F and G instead of H and F. Okay, so you would get a point for that, and then we need to plug pi in for all of our x's. All right, now we need to find f of pi. We don't have that yet, but we do know that this is f of x. And so I'm just going to go over to the side, and I'm going to find f of pi. And you would want to write this down somewhere. It is super important that even if it doesn't tell you to show the steps that lead to your answer, you always need to. And then the cosine of 2 pi is 1. And we already said the sine of pi is 0. So this ends up being 1 plus 1, or just 2. All right. And then we said, everywhere in the problem when it's f prime of pi, we're going to use -1. So this is a good example of if you couldn't figure out what if you just looked at f prime of x and just were like, I can't do that, you can just make something up. So if like you didn't know how to do part A, you could just say f prime of pi and then just make up a number. You could call it 20, whatever. And then every time you needed f prime of pi, you could use that number and you would get credit. So if you just couldn't figure out how to do the chain rule there, just like totally couldn't, just make something up for f prime of pi. And then this is a little easier of a problem. Then you can just plug that in there. But we know what f prime of pi is, that is -1. Okay. Now we need h prime of 2. So let's see what we got here. So h is the graph. So how do we find h prime of 2 on a graph? It's the slope. So when x is 2, it's the slope of this line, which is going to be down 1, right 3, so -1/3. And then you can stop. I mean, it's not hard to multiply this together, but you don't have to. You can stop. All right, now if you need to write yourself a note, you can. You don't have to tell the people that's what you're doing, though, without grading your test. Okay. I like the function mashup questions. You just get to use a whole lot of different things you learned in calculus. All right, let's look at part C. This time we have a whole new function, which is m. And m is g of -2x times h of x. And we want to find m prime of 2. So we're going to start off and we're going to find m prime of x. I'm going to write what m is on here just so I can see it when I'm talking about it. Okay. So what we're going to have to use a couple of rules in calculus for derivatives. What's one that we are going to have to use to find this derivative? The product rule. All right, so on the product rule, it really doesn't matter what order you do it because you're just multiplying and adding, but I'm going to leave the first one alone and then multiply by the derivative of the second, and then plus, I'm going to leave the second one alone. And this is the tricky part. I'm going to multiply by the derivative of the first. So see if you guys can figure out what the derivative of g of -2x is for me. So inside of this product rule, we also had a little baby chain rule where we did g prime of negative 2x, but we had to multiply by the derivative of negative 2. Multiply by the derivative of negative 2x. Okay, so you would get a point for writing that down. And now we just need to plug in 2 for all of our x's. Now, unless you were just really crunched for time, I would recommend that you show where you're doing 2. I just about messed up. Otherwise, if you just are out of time, then you can do negative 2 times 2 in your head and just call that negative 4. That's fine. I think it's a little safer if you show all that, because you never know what they'll give you points for. All right, so G was our table. So from the table, I do need to know G of 4, negative 4, just kidding, G. See, if you messed up and multiplied by wrong, 4 isn't even here, so that would let you know that something's wrong. But yeah, G of negative 4 is going to be 5. All right, H prime of 2, we already found that, was negative 1/3. You could find it again if you wanted to. It's the slope of H when x is 2. Now H of 2 we haven't found. So I need to know what that is. Do you guys know? Yeah, very good. We're going down by 1/3 each time, so that would be 1/3, 2/3, 3/3, so negative 2/3. Very good. And then we're going to multiply negative 2 by G prime of negative 4, which is going to be from our table. That's going to be negative 1. And then we're going to stop. Great, and then for D, the question is there a number C on the closed interval from negative 5 to negative 3 such that G prime of C is equal to negative 4? And then we're going to justify our answer. So if we were just looking at the G primes part, we're going from negative 5 to negative 3. Does negative 4 fall in between those two? Doesn't. So that's the intermediate value theorem. It's a little bit the easier value theorem to use. That doesn't mean that the answer is no, because we have other value theorems, right? We have the mean value theorem where we can actually use the G part of the table. So again, this I feel like this is kind of a difficult question to get right, but it's doable. So for the mean value theorem, I do need to find the average rate of change between negative 3 and negative 5. And let's see what happens when we do that. So because we got that -4, and that's what we were trying to prove is possible, or guaranteed, or there must be, then the answer is yes, there must be. So we have to say all the right things though. So for the mean value theorem, the function must be continuous on the closed interval, and it must be differentiable on the open interval, and that is the case, because we know that it tells you G is differentiable. So since G is differentiable, and thus continuous, and I'm going to go ahead and use the interval. It's that way everywhere, but I'm going to go ahead and use the interval that they gave us. And then I'm going to state the average rate of change in symbol form. So, and then that average rate of change between -3 and 5, or -5 and 3, is -4. And then we have to tell what theorem we used. The mean value theorem guarantees there is some number, and then I'm just quoting the problem. We're going to call that number C. And then I'm going to give the interval such that G prime of C equals -4. Alright, so it seems like a lot of words, but don't forget to quote the problem. So you don't have to come up with all the words. You can use the problem to help you answer it. Okay, so what questions do you guys have? It seems like we practice a lot of mean value theorem and not as much intermediate value theorem. I feel like the one you do today is mean value theorem again. I don't have it up here. So you might want to look back over intermediate value theorem. It's more like you state what G of 3 is, state what G of 5 is, and say that what you're looking for falls in between. And it only has to be continuous. It doesn't have to be different. Okay. All right, let me give you guys your assignment.